Hello everyone. In this section, we are talking about the scalars and vectors. Physical quantities can usually be placed into two categories, vectors and scalars. In this section, we will discuss the differences between vectors and scalars, different methods of representing a vector, and how to add and subtract vectors using the graphical method. Let's start with scalars. Scalar is a physical quantity with magnitude only. Examples: distance, time, temperature, density. When we are presenting these quantities, we just include the magnitude. There is no direction. And also when we are doing calculations with scalars, we follow the general ordinary arithmetics. So when we need to add two masses together, for example, 6 kilograms and 3 kilograms, we can just add them and we can say 9 kilograms. If we want to multiply 2 seconds by 4, we can just multiply and say 8 seconds. When we are dealing with vectors, the direction matters. So vector is a physical quantity that requires both the magnitude and the direction. For example, if we take a force, a car is pushing towards to right with a force of 25 kilonewtons. So we need to include the direction and also we need to give the magnitude. So when we are presenting a vector, we need to include both of these quantities, the magnitude and the direction. The other examples of vectors are displacement, velocity. When we are doing calculations with vectors, we can't do in the ordinary way. For example, if I take a car pushing with 10 newtons, and if I apply another force at the back with 5 newtons, we can add these two and we can say the resultant force is 15 newtons towards the right. But if I change the direction of this 5 newtons to the opposite side, now I can't say 5 plus 10 is equals to 15 because the direction matters. Now the resultant force will be 5 newtons to the right. So we should know the methods to add vectors together. Let's see the notation of vectors. So we can write the vector with bold letter, or else we can use the letter with the arrow at the top. The magnitude of the vector we can represent like this, within the letter within the vertical bars. When we are representing a vector in a graphical way, we use a line with an arrow. So the length of the line represents the magnitude and the arrow represents the direction. We call the starting point of our vector the tail and the ending point of the vector as head. When we are representing a vector using words, we can write referring to XY coordinates, or else we can use the compass direction, north, east, south, and west. First, we'll see how to write the vector using the XY coordinates. So we take the same vector that we had before. So we have 5 newtons applied to the direction given in the arrow. And if we write this vector in the XY plane, we can see it is making 30 degrees with the x-axis. So we have to present the magnitude and also the direction. The magnitude of the vector is 5 newtons, and the direction we can refer to the x direction. So we can say 30 degrees clockwise, counterclockwise direction from the positive x-axis. Or else we can refer to the y direction and we can say 5 newtons, 60 degrees in the clockwise direction from the positive y-axis. If we use the compass directions, this is our north and this is our east. So we can say 5 newtons, 30 degrees from east to north, or else we can write it east to north like this. Or else we can refer to the north and we can write 5 newtons from north to east, 60 degrees. Let's take this example and see the difference between vectors and scalars in more depth. So here we have a person walking from P1 to P5 along the path P1, P2, P3, and P5, P4 and P5. P1 to P2 is 5 meters, P2 to P3 is 2 meters, P3 to P4 is 5 meters, and P4 to P5 is 1 meter. So they're asking us to find the distance traveled and also the displacement. Distance is a scalar and displacement is a vector. We'll first find the distance. Distance is the total distance traveled, total length traveled. So the person is starting from P1 and he is moving to P2, then going to P3, P4, and stopping at here. So we can add all the numbers along this length, the distances, and we can say he has traveled 13 meter distance. Now to find the displacement. Displacement is the vector. He started at P1, so this is the start point. And he stopped at P5, and this is the end. Vector is the difference in the length, so that means the displacement. So start to end difference. So this is our vector. When we are presenting the result for the vector, we need to give the magnitude and the direction. So if I write the magnitude, we can use this triangle and we can write the magnitude using the Pythagoras theorem. So I have 2.2 meters. And also we need to give the direction. So what is the direction for this one? So I can find this angle theta. I can write tan theta as opposite over the adjacent. And I can find theta, which is tan inverse 2. So this direction is from, we can refer the XY directions or else we can refer the northeast compass direction. So I can write east to north, this many degrees. Let's see how to add vectors together. There are two methods to add vectors together, graphical method and the analytical method. In this section, we will discuss the graphical method. When we are adding vectors using graphical method, we draw vectors head to tail. That means, to add these two vectors, I draw the vectors connecting to each other. So I'll start with my V2, and I join my V1 to the head of the V2. The resultant force, or the V plus V2, is given by the start to the end. So this is where I started, and this is where I am ended. So the start to end give me the resultant direction and the magnitude. And also when we are adding vectors, V1 plus V2 is equals to V2 plus V1. So we can either start with V1 or we can start with V2. So the vector addition obeys the commutative law. Let's take another example. A ski skiing 1 kilometer to north and then 2 kilometers to east on a horizontal field. How far and in what direction is she from the starting point? So if the starting point is this, he has traveled 1 kilometer to north and she has traveled 2 kilometers to east. The resultant, or the change in the position, is from start to end. So this is where we started and this is where she ended. So start to end gives the resultant. Using this triangle, we can find the magnitude of this length, which is the magnitude of the vector, and also we can find the direction. So if I write the resultant as R, the magnitude of the resultant displacement is equals to 1 squared plus 2 squared square root of this. We use the Pythagoras theorem to find it. And we can find root 5 kilometers. That means 2.24 kilometers. To find the direction, we use the trigonometric relationships and we can write tan theta is equals to opposite over the adjacent, 2 over 1. So theta is equals to tan inverse 2, which is equals to 63.4 degrees. Now we can write our answer. She is 2.24 kilometers from her starting point. Her direction is 63.4 east of north. So east to north, it is 63.4 degrees. As you see in the previous question, when we are working with the graphical method to find the resultant vector, we create triangles. So we should know the relationships between the lengths and the angles of a triangle. So in your future questions, you may need to use the Pythagoras theorem and this trigonometric relationship for right angle triangle. And also for any triangle, we can use the sine rule and the cosine rule. So sine rule says the length A divided by the sine opposite angle, sine A, is equals to length B divided by the sine B is equals to length C divided by the sine C. The cosine rule says A squared is equals to B squared plus C squared minus 2BC cos A. So we can rearrange the cosine rule in this way, depending on the information that we get. Let's do this question using the method that we have learned. So I have to add two vectors, V1 and V2. V1 is 10 newtons and V2 is 8 newtons. And the directions are given in this diagram. So I'm going to draw the vectors head to tail. I'm starting with the V2. V2 is 8 newtons and it is making 15 degrees to the x-axis. Then I'm going to draw the V1 head to tail. So I'm connecting to the head of this one and I'm drawing the V1. V1 is 10 newtons and it is making 30 degrees with the x-axis. Now the start to end give us the resultant force. We need to find the direction and also the magnitude of this R. To find the magnitude, we can say if this is 15 and if this angle is 30, I can find this angle just by minusing from 180. So 180 minus 15 minus 30 is 135. I know this angle and also I know the two lengths. I'm going to use the cosine rule to find this R. If I write the cosine rule to find the R, I can write R squared is equals to 10 squared plus 8 squared minus 2 times 10 times R cos 135. When I solve this, I get 16.64. This is the magnitude of the resultant force. To find the direction, I'm taking this angle as theta. I can now write the sine rule to find this theta. So I can write sine 135 divided by the opposite length, which is R. We already found R, is equals to sine theta divided by the opposite length, which is 10. Now I rearrange this equation and I make the sine theta the subject. Then I find the theta taking the sine inverse. So theta is 25.14. But the theta is the angle which is making with this V2. To find the angle with the horizontal axis, I need to minus this 15 because I only need this angle. So if I take that one as alpha, alpha is equals to 25.14 minus this 15. So I need to minus this 15. So this is 15. I can find alpha. Then I write my answer. R is equals to 16.64 newtons, 10.14 degrees counterclockwise from the positive x-axis. So the resultant force is somewhere here. Let's see how to subtract vectors. Just take this example, 10 newtons to north minus 6 newtons to north. So I have 10 newtons to north and I have to minus a 6 newtons to north. When we have a subtraction question, we can convert it to an addition question just by changing this to a plus. When we are changing this to a plus, we need to change the vector, the proceeding with this minus, to the opposite side. So I can write this one as, I don't change my 10, which is a positive vector, but I make this minus to a plus. But when I'm doing that, I change this to the opposite direction. Now we have addition question. We already know how to add vectors. I'm drawing the vectors head to tail. So I have 10 newtons to north. Then I connect the head of my tail of my next vector to the head of the previous one. So I draw 6 newtons down. I started here and now I'm ending here. Start to end give me the resultant, which is this one. So this one is, we can say it is 4 newtons up or 8 to north. So that is how we convert a subtracting vector subtraction to a positive addition question and solve the vector subtractions. Thank you.